Hello, Sampford Peverell Primary School. Happy STEM week, my favourite week of the year, even better than Christmas. I am Adam Lambert. I am Brannick's daddy, and I'm going to talk to you about a job that I actually used to do. I used to work for a company called Rolls-Royce, making jet engines. So this is a picture of, I'm sure most of you can recognise what it is, of an aeroplane. It's an Airbus A380. And on the wings there, on one wing, you can see four airplane jet engines. Sorry, no, two airplane jet engines. And there are two on the other side, making four altogether. So I used to be involved in making and improving these engines. Um, Now, Rolls-Royce itself is a massive company that actually make lots of different things, but I would say airplane engines are not cars. The cars, by the way, interesting fact, is owned by a company called BMW, who they actually make the Rolls-Royce cars now. But the main thing they make are jet engines, and I actually have a model of a jet engine here. So this is sort of without the casing. You see there's a big casing around it when you see it on the airplane, and you take that casing off, this is what's underneath. Um, Narrow in the middle. So just I thought I'd tell you the basics of how these work. It is a principle called suck, squeeze, bang, blow. So air is sucked into the front. You recognize this being the front. Okay, air is sucked into the front and then goes down this middle chamber, squeezed. You put fuel in here where it goes bang, because you light it, it's constantly burning and then blows out the back. Now, how does that all happen? Well, if I spin this around, it's got a bit cut through. So again, I'll talk about the same thing. Air is sucked in. It goes into this little channel here with these things spinning around. It's got a compressor. Then in here is where the fuel is sprayed in, and that goes constant fire, and then it goes boom, blowing out the back there. And actually, this fan on the front, not only does it suck air in, it also blows it around this bit here to make the whole plane go fast, very fast forward, hundreds of miles an hour forwards. Okay. Now, a couple of interesting random facts about airplane engines. So this blade is, oh, I need to get this back up again. It's actually one of the blades on this bit here. It's the hottest part of the engine. It's also the bit that does the most power. So this one blade, there are over 100 of them in the engine. This one blade has the same power as a Formula One car. It also is deals at a temperature so hot that it should melt. And it can take a force that if I hung it upside down, two double-decker buses could be hung off it. It's that strong. It's something called a single crystal nickel alloy. Very fast. Now, I could talk about that for about an hour, but I don't want to keep you for an hour. I want to tell you more about my job. Okay, so how did I get into it? I started Rolls-Royce straight out of university as a graduate trainee. So even though I had this master's in physics and a degree, I still had to learn. So they put me through some training courses, and they put me in lots of different places in the company for short periods of time, which was amazing because I went to Hong Kong for a year. I worked in Derby for 6 months, in Sheffield for 6 months. And then when I'd done a couple of years of that training, I then went, and I was doing work on the job whilst training, but then they put me in a more permanent job in Derby, and that was making the Trent 900 engine, which is on that aeroplane there. So I was in a systems design team in Derby. Now, we had about 50 people in our office working on that engine, and that engine was already flying. So our job was we'd get sort of information through about how it was performing, and there were lots of small faults. Such a massive engine, loads of things going on, loads of moving parts. There were loads of small problems, and we were constantly doing redesigns of parts for the engine to fix a big problem, or little changes to fix a small problem. We also thought we could make it better, so we were doing big design ideas to make the whole engine better. So we were still building these engines and selling them brand new. So the new ones would come out, would have this better stuff that we designed. And the ones that were currently flying, when they came off for repair, then we would put the better stuff in so that they would be flying with this better stuff. And I So I spent, sometimes I would be doing calculations, sometimes I'd be talking to people that were specialists in different areas of the engine and asking lots of different people to do small things. And my job was often to just bring a lot of these other people together, a lot of these really clever people that have their own specialities, and ask them how can we, fix this area of the engine to make it faster. Realistically, I have to admit a lot of it was sat at a desk. I did get to go down and see the engines quite a lot when I was in Hong Kong. I worked on um, a repair site, so I was down with the engines quite a bit, but I never actually really did a lot of the hands-on stuff. I was quite a technical office sort of person, doing computer programming on the computer, doing calculations on a calculator, using the math skills that you guys are learning in school at the moment. I got to go, I got to go to lots of meetings with really important people, talking about stuff, giving presentations, showing people my work and what we were doing and explaining, talking to Airbus, which is the company that makes aeroplanes. So that was one of our big sort of people that we had to deliver the engine to. And they were in France, so we have to talk to them online, or sometimes I'd have to go to France and meet them and talk to them about stuff. So I did have quite a lot of variety on that front. Right, I want to talk about how I got into that position. So I worked obviously really hard at school, but not just in school, but doing all the extra stuff that wanted to do. Because in these sort of companies, you need to be good at talking to people. You need to be good at thinking about different problems. So you also want to get stuck into everything around all your hobbies, all the fun stuff you can do, as well as focusing on different aspects of school. All the subjects all have their own benefits working together. Obviously, when I got through school, I realized I liked science so much and math so much that when I went and did my A levels at the end of school, I mainly did sort of physics, maths, chemistry subjects, and then I went, and that got me on to go to university. I went to Durham University to go and study physics specifically, not actually engineering, even though I was technically an engineer in my job. I studied physics. Um, and then when I was doing my degree, I got work experience at Rolls-Royce, and then followed from that was a full-time job. I had to apply for the job. They had me 2 days of interviews and making me give presentations and doing challenges and exams. It was quite rigorous actually, but really good fun. I was doing it with a bunch of other people that were like-minded. Yeah. So I got loads of amazing questions from you guys. I tried not to cover too much of this stuff there. So, right, what are the questions? I'm going to do, I've got 8 questions. I've got 4 sort of about more engineering-y, sciencey questions, and then 4 more about the job. Okay, so what qualifications and grades did I have to get? This is from Oscar S. So to be an engineer in that sort of more technical environment, you do have to have a degree, and often even a master. So that means going to university. I did get quite good grades to get to a good university. And at my university, and when you do a university degree, you get graded on different things. And yeah, I did have to get a sort of one of the higher grades, a first class or a 2-1, to get onto it. Okay, I'm going to go to an engineering one now. This is from Eva. How much do the engines cost to design and make? Well, I don't necessarily know. There's a lot. I mean, we're talking hundreds of millions of pounds into the whole project of designing a new engine. And then when we sell them, the approximate price of one engine is £1 million. And so you got to think that airplane's got to do a lot of journeys to make up that money. If they, to make it back, it's a lot of money. Okay, job one. Why did I pick that job? Well, I love science, I love engineering, I love maths, and I just thought it was really cool. Sort of, thing to work on these airplane engines, but also the company itself. And this is what I think is really big when you go to in the job world, seeing a company, it just had amazing people. I went to visit it and everyone was really friendly. Everyone was really excited about the job, really wanting to work at it. And I think that is massively important. That was a big selling point. It was also a company where you could move around a lot. I said I went to Hong Kong for a year, and if I'd stayed in the company, I could have done loads of other stuff. But obviously, I wanted to come to Devon instead. And there are, the closest place to here where Rolls-Royce work is Bristol, so it's not exactly far away at all, very close. Oh, where's my questions gone? Sorry, I lost my questions. Next engineering one. How many people did it take to design and make an engine? Well, for Rolls-Royce as a whole, there are 20,000 people working for it. I would say when you're making a new jet engine, you're probably talking about 1,000 people working on the engine. Now, not all of those people are working just on that engine. They have other stuff they're working on too. You probably have about 100 people working only on that engine. When I was doing it, there was about 50 because the engine was already made. It was already flying, so we didn't have as big a team. But when it's a brand new one, you talk about 50, about 100 people working full time, and then overall about 1,000 different people doing the design, doing the build, working out how to actually make the parts, because you design this really cool part and then you have to somehow make it, and then you have to make thousands of them and then you have to build them into the engine. So there's a lot of people involved on that front. Okay, next question. What are we on? Engineering then this time. Oh no, it's work one. How many hours a day did I work? So I probably worked, number of hours, eight to nine. It wasn't too bad. The engineering world can be quite good on that front. You don't always work a huge amount of hours. But it was good. I enjoyed the hours I worked. So I probably started at 8:30, left sort of 4:45, 4:30, sort of 5 o'clock kind of time, Monday to Friday. Reasonably kind of normal, not too crazy, not too crazy. When something big was happening, I might stay a little bit longer. I'd vary, but not too much. Okay, what have we got? How do you get the engine off to work on if they need repairing? Right, repairing. So there's two types. You can often actually repair a lot of the engine while it's on the wing, while it's waiting for the next flight. And the little repairs you can do, a lot of checks that you do. You use little cameras to get into the engine to see what's happening. Um, but the main thing is you'd have to take the engine off, and that would be the whole airplane would come into a hangar. It's a big job. It'd take a whole day to just get the engine off, and then it'd get transported to a big facility that was designed for fixing the engine. Sometimes you'd only fix little bits of it, and you wouldn't have to do much. Or sometimes you take the whole engine pretty much apart, check all the parts, put them all back together again, replace the bits that aren't working properly, and then and make it go. And then that's when you can put all the extra improvements that you want to put into it as well. What else we got? So job one, was it fun? I've said this a few times. Actually, yes, it was overall really good fun. Yeah, it was hard work, definitely hard work, but it was good fun. I did enjoy the job. Number four, are there different engines for different planes? Absolutely, yes. So the planes, for example, you have on a fighter jet that the army might use, that would be a smaller engine that's designed purely for going really fast, but uses loads and loads of fuel. Whereas these ones, the one that I got out here, you see how it's got this bit that goes around the side. It's really big at the front, but small at the back. There, all the air is going around the side. That's designed for going not as fast, so quite fast, not as fast, but making sure it doesn't use too much fuel, because that's a lot better for the companies that are trying to earn money, but also much better for the environment to not burn loads of fuel. And that's something huge about my job that I didn't really mention. What was our main aims of making these engines? We want to make them as efficient as possible, which means go as far as possible with as little fuel, because then you'd better for the environment and better from a money point of view as well. But also there was looking at making them not too noisy. Surprising amount of engineering goes into making airplane engines not too noisy, because if you live near an airport, it can be very noisy, and that's a big thing you have to do to get them going. Right, I'm just going to check my notes before I sign off. I'm just going to check that I haven't missed anything that I wanted to mention. No, looking good. Should I do a random one last question? Is it dangerous to be around the engines? I'm going to do that. Danger. Not. I mean, you're not really around them when they're on. So no. We do these tests on the engines as well. So when we making new engines, loads of tests you have to do, so it gets a pass to say, yeah, you are allowed to fly. And I'll tell you about one of the really cool tests you do, is that in order to check that the blades don't fall apart when they hit things, like for example, birds that might fly in there, we do a bird strike test. So we actually set it up on a big test. It's not on an airplane at this time. It's just strapped into a big sort of crane, and then we fire chickens at it, dead chickens. dead chickens, not live chickens. We're not really mean, okay? Dead chickens that wouldn't be used for eating anymore. We fire those at the engine, and the blades have to sort of have to get sucked through the engine without damaging the blades. And they can survive that quite well. As long as there's not too many at once, it can survive that really well. And then with the same plane, we'll actually blow up one of the blades and see if the whole engine survives. It obviously won't keep running, but you want the whole engine to not fall off the airplane and explode. And it can take one of those big blades. It can take one of those big blades going and getting sucked through the engine. Like one of these ones at the front. One of these ones, which is huge. I mean, this okay. I in real life, I would almost be able to stand inside this. Okay, so you can think of how big one of these blades are, and the engine will not fall apart. It will stay there. It won't work anymore, and the airplane can glide down to the bottom. Okay, I could go on forever. I've already gone on for almost 15 minutes. So, if you see me in the outside of school with Bran, feel free to ask me any other questions. I hope you have an amazing science week. And any follow-up questions, I'm actually more than happy if you want to give me some follow-up questions. I don't know if that's an option, but from what I've said, hope you have a lovely science week, and I'll see you guys soon.